Well, hello everybody. Welcome back to Philosophy. My name is Professor Paul Hicks, and today we're going to talk about the methodology of philosophy. That is the area of philosophy called logic. What is good reasoning versus what is bad reasoning? What is logic? How do we know that some statements derive from other statements? That's what I want to talk about today. So remember, for philosophy, it's not about mere opinion. We are trying to reason well to get to certain conclusions about maybe the nature of the universe, the nature of reality, the existence of God, the existence of time, or what is right or wrong, or what have you. We're trying to come to a position that is well reasoned. Well, what does it mean to be well reasoned? What philosophers employ is logic. So what is logic? Logic is the study of arguments. So philosophers are going to create arguments for the positions that they actually have. So the first question that we should really ask is, what is an argument? What actually is an argument? So, an argument is not what happens, say, in a parking lot when somebody takes your spot, right? And you get upset with them and have an argument. That's not what an argument is in academics. An argument in academics is where somebody's trying to prove something to you and they're giving reasons for why it is they believe whatever it is that they actually believe. So I'm going to go ahead and give you the definition of an argument here. So an argument, by definition, is a set of statements such that one statement is supported by the others. So let me go ahead and give you an example of an argument. If you look at this first argument, it's probably one of the most famous syllogisms in all of philosophy. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Now, let's take a look at this. There's actually three claims here, right? Number 1, number 2, and number 3. Notice here that if the first and second statement are true, what is the truth value of statement number 3, the last one? It has to be true, right? Because if statement 1 and 2 are true, 3 must follow out of necessity. This is what we're actually calling an argument. These are 3 statements, and one of the statements is thought to be supported by the others. So statement number 3 is supported by statement 1 and 2. So let's go through this real quick. Let's look at statements 1 and 2. These statements are just purporting that there's certain facts about reality. That is, all men are mortal. They're stating this as a fact. Or Socrates is a man. They are stating this as a fact. Okay, well, these statements, when they are doing the supporting of the other statement, are what we call premises. So the definition of a premise is any statement in an argument that supports the conclusion. It is a supporting statement in an argument. Now, let's take a look at statement number 3. This is going to be a conclusion. And so the definition of the conclusion is the supported statement in the argument. Ultimately, what the conclusion is somebody is trying to prove something to you, and it is whatever it is they're trying to prove. Whereas the premises are the reasons that somebody is giving for proving a certain statement to be true. That is the conclusion itself. Okay, so that's what an argument is, and those are the basic components of an argument. But there's more to understand about arguments than just their components. So let's go ahead and just go through and think about some basic arguments here. Okay, you've come across arguments all the time in your life. So let me go ahead and give you this set of statements. Fuzzy Wuzzy was a bear. Fuzzy Wuzzy had no hair. Fuzzy Wuzzy wasn't very fuzzy, was he? Okay, is this an argument? Well, it is. What is it that somebody is trying to prove to you? They're trying to prove to you that Fuzzy Wuzzy's not fuzzy. Now, did they give you any reasons for why it is that they believe Fuzzy Wuzzy's not fuzzy? They did. Fuzzy Wuzzy has no hair. Now, we recognize now that Fuzzy Wuzzy has no hair, and we have a conclusion that therefore Fuzzy Wuzzy is not fuzzy. We're actually missing a premise here. I'm going to go ahead and put it in as premise number 2, that to be fuzzy, one must have hair. Now we actually have the argument. Fuzzy Wuzzy has no hair. In order to be fuzzy, one must have hair. Therefore, Fuzzy Wuzzy is not fuzzy. Okay, that is actually an argument. Now compare it to, say, a non-argument. one that you're probably familiar with. Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown, and Jill came tumbling after. This is not an argument. This is what we call a narrative. Nobody's trying to prove or to get you to accept some sort of position. They're just saying what happened. Jack and Jill went up a hill. No, right? It's not a premise. Jack fell down and broke his crown. Jill came tumbling after. One event happened, then another event happened, then another event happened. All right, so those are arguments. Somebody's trying to prove something to you, not just relaying events. Okay, now when we talk about arguments, there's going to be two different types of arguments that you need to know. Deductive arguments versus inductive arguments. So let's talk a little bit about what the difference is. A deductive argument is a type of argument where it is thought the conclusion is guaranteed by the premises. So let's take a look at the argument we were looking at just a little bit ago. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Now, I want you to compare that to another type of argument. This is what we're going to call an inductive argument. So let's look at this other argument here. Most Greeks like olive oil. Socrates is Greek. Therefore, it is likely that Socrates likes olive oil. Okay, you notice here that in this argument number 2, if the premises are true, doesn't guarantee the truth of the conclusion. If the premises are true, does it actually guarantee the truth of the conclusion? Is it possible that Socrates doesn't like olive oil? Right? So if we're looking at premise number 1, it says most Greeks like olive oil. It doesn't say all Greeks like olive oil. It just says that most. So let's say, for the sake of argument here, 90% of Greeks like olive oil. It is possible, logically speaking, that Socrates is within the 10% that does not like olive oil. But notice in the first argument, where all men are mortal, Socrates is a man, therefore Socrates is mortal. There's no way around getting that conclusion from those premises. That if those premises are true, then that conclusion absolutely has to be true. All right. So a deductive argument is one where the conclusion is supposed to be guaranteed by the premises. An inductive argument is one where the conclusion is, at best, more likely than not based upon the premises. So it's always possible in an inductive argument to have true premises and a false conclusion, but that doesn't mean that the reasoning is bad. It just means that we can't have absolute certainty about it. Okay, so I want to introduce you to some more terms when it comes to arguments. If an argument is deductive and it has what we call logical strength, then we're going to call it valid. So what do I mean by logical strength? So logical strength is to say that if the premises are true, then it's likely the case that the conclusion is true. In the case of inductive arguments, it is to say that if the premises are true, then the conclusion must be true in the case of deductive arguments. So I'm not saying that the premises are true here yet. I don't want you to say that just because an argument has logical strength doesn't necessarily mean the premises are true. So let's go ahead and take a look at this argument here if we can. All dogs play baseball. All baseball players have blue hair. So what's going to follow if those two statements are in fact true? All right, all dogs play baseball. All baseball players have blue hair. What must follow from that is all dogs have blue hair. Now, you don't believe that that conclusion is true. You don't believe that all dogs have blue hair. But why? Well, that's because you believe one of the premises is actually false. Right? We can go through specifically, all dogs play baseball. That is a false premise. But notice that if I was to say, if those premises are true, then the conclusion actually must be true. There's no way around it. Right? If the premises are true, it makes it impossible for the conclusion to be false. This is a deductive argument. And when a deductive argument has logical strength, what we know is that it's logically speaking impossible for premises to be true and a conclusion false. When that is the case, we call the argument valid. So a valid argument is one where if the premises are true, it is impossible for the conclusion to be false. Now notice that we say if the premises are true, it's impossible for the conclusion to be false. That requires that it's deductive. So when I have, say, an inductive argument, that would never be valid because by definition, an inductive argument is one where it's possible for the premises to be true and the conclusion false, but a valid argument does not allow for that. If it's an inductive argument and say it has logical strength, then we call it strong. So a strong argument is the logical strength of an inductive argument. So take, for example, the following. 90% of Americans believe in God. Joe is an American. Therefore, it is likely Joe believes in God. This is an inductive argument. Now let's say if those premises are true, does that mean that the conclusion is likely to be true? Notice we can't guarantee that Joe believes in God because he might be in the 10% of Americans that don't believe in God. That's a logical possibility. But if those premises are true and that's all you know about Americans and Joe, then it's pretty good reason to think that Joe believes in God. But it's always possible for the premises to be true and the conclusion false, but it is still a strong argument. If an argument is inductive and those premises don't support the conclusion, we call it weak. Okay, so now we've looked at the logical strength of an argument. Now we need to go a little bit further. Now, instead of just looking at the logical strength of an argument, now I want to know, are the premises also true? So in the case of a deductive argument, if we've established that an argument is valid, then we need to establish that the premises are actually true. Because an argument can be valid and have all false statements and still be valid. So, going back to all men are mortal. Socrates is a man. Therefore, Socrates is mortal. So if you look at statement 1 and statement true, are those true statements? Is statement 1 true? All men are mortal. Well, yeah, we're all going to die. Socrates is a man. We'll just accept for the sake of argument that that's true. Well, if those two are true, then the conclusion must be true because it's deductive, it's valid, and the premises are true as well. Remember, for validity or for logical strength, an argument can have logical strength even if the statements are false, even if the premises are false. But if it is valid and the premises are also true, we're going to call this sound. So a sound argument is a deductively valid argument that has true premises. All right, so think about that. A sound argument is a deductively valid argument with true premises. Okay, well, let's go ahead and look at the cousin argument of the inductive argument. So an inductive argument that has logical strength, we call it strong. If it does not have logical strength, we call it weak. But what if it is a strong argument and the premises are also true? If it's a strong inductive argument and the premises are also true, we can't call it sound because soundness is a property of deductive arguments. We call it instead cogent. So a cogent argument is a strong inductive argument with true premises. Okay, so let's just talk about these two for just a bit. An inductive argument is always one where if the premises are true, the conclusion can be false. And valid argument is the logical strength of a deductive argument. A valid argument says that it is impossible to have true premises and a false conclusion. So once again, by definitions of these terms, an inductive argument can never be valid. And we would never call a deductive argument strong because there's more to it than that. There's more force behind the premises that drives that conclusion into a deductive argument. If I ever tell you that this is a sound argument, then you know immediately that it's valid and that the premises are true. All right, at least then I'm making that sort of claim that that's the case. Now in logic, we can actually prove with mathematical certainty whether or not an argument is valid. I'm not going to do that here, but if you were to take a logic course, that would be something you would learn how to do. Okay. Now I want to talk a little bit about the form of arguments if I can. So there are deductive arguments and there are inductive arguments. And arguments also have a form. So what do we mean by that? Let's go ahead and take this particular argument. If it is raining, then the streets are wet. It is raining, therefore the streets are wet. So let's go ahead and look at, say, the first statement. If it is raining, then the streets are wet. Notice what one thing I can do here is look at if it is raining. That is a simple statement. The streets are wet. That is another simple statement. But when we say if it is raining, then the streets are wet, that now becomes a complex statement. All right, and the truth value of a complex statement is dependent upon the truth value of the individual simple statements. So rather than writing, if it is raining, then the streets are wet, here's what I'm going to do. I'm just going to say, if P is true, then Q is true. Where P stands for, in this instance, it is raining, and Q stands for, the streets are wet. So now we're going to have a logical form. Look at it this way. Statement number 1, if P is true, then Q is true. Statement number 2, P is true. And then statement number 3, therefore Q is true. Notice how the reasoning in the argument that I gave you about if it's raining, then the streets are wet, it is raining, therefore the streets are wet. You notice how it takes a particular form? So I'll give you another one. If I have a cat, then I have a mammal. I do have a cat, therefore I do have a mammal. Once again, you notice how it takes these this particular form, right? There's a particular form of reasoning which is happening here. And we can go ahead and understand that form if I was to write it out. If P is true, then Q is true. P is true, therefore Q is true. All right. Now, we have this argument is so common that philosophers have actually given it a name, and we call it modus ponens. All right? So a modus ponens argument is any argument of the form, if P then Q, P, therefore Q. Okay, sometimes people make mistakes. So in the example that I gave you, P is what we call the antecedent, and Q is what we call the consequent. So in the statement, if P is true, then Q is true, P is the antecedent and Q is the consequent. Sometimes, rather than affirming that the antecedent is true, some people make the mistake and try to affirm that the consequent is true. So for example, they would say, if P is true, then Q is true. Q is true, therefore P is true. All right, this is an invalid argument, and this would be an erroneous argument. So an example of that would be, if I have a cat, then I have a mammal. Well, I do have a mammal, therefore I do have a cat. That's not true. That's not going to be good. It's possible that those statements are all true, but isn't it also possible that if I have a cat, then I have a mammal is a true statement? I have a mammal, but the mammal that I have might be a dog or a hamster or a little bunny rabbit. Right? So that's not going to work. That is what we call affirming the consequent, and that's an erroneous way of reasoning. So the first one we talked about is modus ponens. Now I want to go ahead and introduce another type of argument form called modus tollens. Modus tollens takes the following form. If P is true, then Q is true. Not Q, that is, Q is not true, therefore not P. So for example, if I have a cat, then I have a mammal. I do not have a mammal, therefore what must be true? I do not have a cat. You notice that if those premises are true, then the conclusion is guaranteed. It is a valid logical form, and any time an argument takes that form, we know that it is in fact a valid logical form. So let's go ahead and see a common error when people try to apply modus tollens. There's what we call denying the antecedent. And denying the antecedent, somebody might say, for example, if P is true, then Q is true, P is not true, therefore Q is not true. That doesn't actually work. We can't say something like that. That would be erroneous. So, for example, if I have a cat, then I have a mammal. I do not have a cat, therefore I do not have a mammal. That's not necessarily true because I have other animals, say a dog and a bunny. All right. So denying the antecedent is erroneous and invalid argument, where the modus tollens is a valid argument. All right, now let's go ahead and look at another logical form. This one's going to be called the disjunctive syllogism. And the disjunctive syllogism goes like this. Either P is true or Q is true. P is not true. Therefore, what must be true? Q. So let's go ahead and give this another a good way of thinking. So either I have a cat or I have a dog. I do not have a cat. What must be true? That I have a dog. This is a logically valid argument. Anytime there is an argument that takes this form of the disjunctive syllogism, it is a logically valid argument. Now, some people will say, make this kind of mistake of what's going to be called the dysfunctional syllogism. That is this form. Either P is true or Q is true. Q is true, therefore not P. No, not necessarily. So once again, either I have a cat or I have a dog. I have a cat. Does that mean I don't have a dog? Isn't it possible that I have both a cat and a dog? And as long as that's a logical possibility, then the argument's going to fail. So the dysfunctional syllogism is going to be an invalid argument, whereas the disjunctive syllogism is going to be a valid argument. Okay, I want to go ahead and introduce a new form of argument, and that's what we're going to call the hypothetical syllogism. The hypothetical syllogism is a chain of reasoning. So, for example, it says, if P is true, then Q is true. If Q is true, then R is true. Well, what do I know? I know that if P is true, then Q is true, and if Q is true, then R is true. Then I know that if P is true, R must also be true, right? This is a hypothetical syllogism. So, for example, if I have a cat, then I have a mammal. If I have a mammal, then I have an animal. Therefore, if I have a cat, then I have an animal. That works. Those premises guarantee the truth of that conclusion. That is, it is a deductively valid argument. Now let's go ahead and look at where people might go wrong trying to use this argument. And this is what we're going to call an illegitimate syllogism. So in this one, you can say if P is true, then Q is true. If R is true, then Q is true. Therefore, if P is true, then R is true. That's not going to work, right? If I have a cat, then I have a mammal. If I have a dog, then I have a mammal. Therefore, if I have a cat, then I have a dog. Just because both cats and dogs are mammals doesn't mean that if I have a cat, I must have a dog, or vice versa. So that's not going to work. This is what we call the illegitimate syllogism, and that type of argument is always going to be invalid. Okay? Let me go ahead and give you another one. This is going to be the dilemma. In the dilemma, you're going to have to go between one or the other. So for example, either P is true or Q is true. If P is true, then R is true. If Q is true, then R is true. Then what do we know? We know that R must therefore be true. Look, what we're saying here in the first premise is that if P is true, that either P is true or Q is true. So we know one of them is true. Now we say if P is true, then R must be true. But if Q is true, R also must be true. And since we know at least one of them is true, we must know that R happens to be true. Okay? So that's going to be a dilemma. Where do people actually go wrong there? Well, they make a fallacious reasoning when they use the false dichotomy. So a false dichotomy is where somebody's going to say either P is true or Q is true. If P, then R. If Q, then R. Right? Notice here that you can't derive R because there might be another reason about P and Q. So maybe it's P is true, Q is true, S is true, something like that, right? If we say either P is true or Q is true or S is true, then we won't be able to establish R unless we can also establish that S or any others also imply R. Okay, so those are deductive valid argument forms versus their invalid argument forms. Those are important to know because when we go on in philosophy, we're just going to say, hey, this argument is, say, a modus ponens, or I know this because of modus tollens. So keep those in mind. Those are all also deductive arguments. Remember, we're talking about validity versus invalidity. So if an argument is valid, we know immediately that it's a deductive argument, not inductive arguments, because by definition, inductive arguments can never actually be valid. Okay, now I want to go and talk to you about a couple argumentative forms for inductive arguments. So let's take a look at just some inductive arguments here real quick. Let's say the Los Angeles Zoo has swans, and although I haven't seen them, they must be white. Okay, let's reconstruct this particular argument. One way I could do it is to reconstruct it as follows. One, the first premise, the Los Angeles Zoo has swans. Two, there's an assumption here that all swans are white. Or three, is our conclusion, therefore, the swans at the Los Angeles Zoo are white. Do we really mean to say that all swans are white when we actually said that statement? It seems to be the case that somebody actually said that, but is that what somebody actually means? Isn't it probable that they probably should be reconstructed inductively? So for example, we could say the Los Angeles Zoo has swans. All of the swans we have observed so far have been white. Therefore, the swans at the LA Zoo are likely to be white. See, we're not making as strong of a claim here with an inductive argument. We're not saying that all swans have to be white. We're just saying at least the ones we've seen have been white, but we haven't seen all swans, so we don't really know. Okay, there's going to be 4 inductive argumentative forms that I want you to know. The inductive generalization, the statistical syllogism, the induction by confirmation, and analogical reasoning. So let's go ahead and go through these arguments really quick, or these types of the form of these arguments. An inductive generalization is an argument where you're going from a smaller group to a larger group. You're generalizing about the smaller group to go to a larger group. We see this in polling all the time. Say if it's a year of the presidential campaigns, and they'll say, well, 55% of voters are going to vote for Senator Jones, right? Well, how do they know that? They didn't actually ask every voter. They used an inductive generalization. Okay, so an inductive generalization is the following. Z% of observed Fs are Gs. Therefore, it is likely that Z% of all Fs are Gs. So, for example, let's go ahead and give some real simple examples of this. 55% of observed voters say that they're going to vote for Senator Jones. It's likely, therefore, that 55% of all voters are going to vote for Senator Jones. Or 80% of my students in the past have passed my class. Therefore, it's likely that 80% of students in all of my classes will pass my class. Right? Something like that. That is an inductive generalization. We're going from a small observed group to the larger group at hand. Now, what's going to make an inductive generalization stronger or weaker? Notice, unlike deductive arguments that are either total support or no support, an inductive argument kind of has more of a spectrum. That is, it can be stronger or it can be weaker. So what we want to look at is representativeness and bias. So with an inductive argument, let's say I was to do a survey about how many Americans believe in God. Well, if I went to a church parking lot on a Sunday morning and asked people randomly, hey, do you believe in God? Am I going to get the same percentage as, say, all Americans? Absolutely not. Right? Because if you go to a church parking lot on a Sunday morning where presumably everybody believes in God, that doesn't mean that you can go ahead and extrapolate from that sample to the larger sample. It needs to be representative of the population at large. Okay? All right. Let's go ahead and think of another one, another argument form, the inductive argumentative form called the statistical syllogism. Now, unlike the inductive generalization, it goes from the smaller to the larger, the statistical syllogism is going to go from the larger to the smaller. So, for example, we might say 90% of Americans believe in God. Paul is an American, therefore it's likely that Paul believes in God. Is that conclusion true or not? Well, it's going to depend on whether or not those statements are true, and then if you don't know anything else about, Americans and Paul. So a statistical syllogism is any argument that takes the following form. Z% of F's are G's, X is an F, therefore it's likely to the degree of Z% that X is a G. All right? So we're talking about what most people are and going down to a very particular person about their belief. Think of it this way. What's going to make this weaker and what's going to make this stronger? Well, we have to look for what we call defeating propositions. So if we took the argument that 90% of Americans believe in God, Paul is an American, therefore it's likely Paul believes in God, is there a defeating proposition? That is, any statement that, if known, would render the conclusion false. So, for example, let's say we find out some new information. We find out that Paul is the president of the American Atheist Association. Now, if Paul's the president of the American Atheist Association, is that argument strong or weak? You notice it's weaker because the likelihood of the statements are going to be false, right? So for a statistical syllogism, what you're looking for is any defeating propositions, any statements that, if known, would defeat the conclusion actually being true. Okay, let's go ahead and move on to another type of inductive argument, and this is going to be the induction by confirmation. Ultimately, this is the style of reasoning that happens in science. So it has the following form. If my hypothesis is true, then these observations should obtain. These observations do obtain, therefore it's likely my hypothesis is true. So what are we doing in science? Right? We're forming some sort of hypothesis. We're forming some sort of guess based off observations. And then we say, let's go ahead and test it. I'm going to test my hypothesis, and I want to see what happens, right? What happens once I test it? What observations do I actually see? Well, if I see those observations, then it's likely my hypothesis is true. I might be wrong, right? I might be wrong, but it strengthens it. So, for example, if I were to say something along the lines of, if my car battery is dead, then my lights won't work. Okay, so, if I'm saying if my battery is dead, then my lights won't work, my radio won't come on, the car won't turn over, something like that. So let's say I go out to my car and the lights don't work, the radio doesn't come on, and my car doesn't turn over. Why? Well, it's probably because I have a dead battery, right? So I had a certain hypothesis about whether I had a dead battery, and I said, hey, if I do have a dead battery, these observations will obtain. Those observations do obtain, therefore I probably have a dead battery. Notice, however, I might be wrong. Notice that it is possible maybe something else is going on. Maybe I don't have a dead battery. Maybe somebody just disconnected my battery cables. Maybe there's something else going on with my car. I don't know. But I can't say with certainty. Therefore, it's inductive. Okay? Now, what's going to make an induction by confirmation stronger versus weaker? Well, an induction by confirmation is going to be stronger the more observations that can be predicted. The fewer observations that can be predicted is going to make it weaker. So, what you want is to try to predict a lot of observations to see if they obtain based off that hypothesis, because then that's going to strengthen your hypothesis as actually being correct. All right, you might be wrong, but that doesn't mean that it's bad reasoning. Okay, there's one more type of argument, of inductive argument, that I want you to know, and that's analogical reasoning. What we're talking about in analogical reasoning is we are comparing two facts or two claims, right? What we're going to call analogs. Now we can reason by saying the following. This is going to be an analogy by property. All right. So take the following. Object X has properties A, B, C. Object Y has properties A, B. Therefore, it's likely that object Y also has property C. Okay, so let's go ahead and try to give an example of this. Non-human mammals are warm-blooded, have a heart and lungs, sexually produced by live birth, share a number of other features common to all members, and can be cured of cancer. Humans are warm-blooded, have a heart and lungs, sexually reproduced by live birth, and share a number of other features common to all mammals. Therefore, it's likely that humans can also be cured of cancer. Now, is it possible that we're wrong? Sure. Maybe it's easier to kill, cancer in non-human mammals. That's a possibility. But you notice this is how we do animal testing, whether that's right or wrong. This is in fact what's happened. What we're saying is that that non-human animal and the human animal are close enough that we can extrapolate some sort of data simply by, looking at one and then the other. All right. So this is what we're going to call an analogy. All right. So, we've gone over 4 inductive argumentative forms. That is the inductive generalization, the statistical syllogism, the induction by confirmation, and analogical reasoning. I want you to know all 4 of those because later on in the class we're going to talk about those, and philosophers are going to have these types of arguments, and I need you to know what's going to make the argument stronger or weaker in the case of inductive arguments, and what's going to make the argument, say, valid or sound in the case of deductive arguments. So it really is actually important to know this stuff. I know it may sound just like a bunch of extra stuff you shouldn't need to know, but it is important that you understand that philosophy is not about mere opinions, but rather about what we can argue for, what is logical. That's what philosophy is about, so keep that in mind. All right, thank you for watching. I will see you next time.